Assalamualaikum warahmatullahi wabarakatuh to all students and parents. So this is our online distance learning with me Abdul Kabir bin Rahmat from Faculty of Business Management and Malaysian Institute of Transport UITM. So stay at home, stay calm and keep on learning.
Assalamualaikum and good days to everybody. So today will be the continuation of our business analytics class, MGT 555. So we'll be discussing on how to solve some of the exercises which I have assigned to you guys. Question one, eh? So we have 8 questions. So we just go on one by one. First one is the data obtained from a country auditor in the Excel file, home market value. Provide information about the age, square footage, and current market value of houses along one street in a particular subdivision. So, considering this data as a population of homeowners on the street, compute the mean, variance, and standard deviation for each of these variables using spreadsheet and formulas given. So, this is the formula, which is population mean since the data given is about population. So you need to use since it asks you to calculate to find out the mean, variance, and standard deviation for different variables, age, square footage, and current market value. So you need to find out the mean, the variance, and standard deviation. So the formula is this one, population variance, whereby in order to use the population variance, you need to use this formula. So let's check it out. So this is an empty blank Excel file. So this is the data. You have your house age. So you have your house age, square feet of the house, and so after you have calculated the mean, you actually need to, in order to get the variance, and in order to get the variance, you actually need to calculate the observation minus mean, and then you have to get the power of 2 of your observation minus mean. So observation minus mean here is equal to house age minus mean. Okay, that's it. Then just double click it. Oh, actually you can't double click. Just drag down. Okay, so this is example of wrongly done. Why? Because once you actually drag it down, you can see the formula is moving. Okay, see? So it's moving here, and further down it's moving down here. So the best way is to lock this formulation while placing down dollar signs. So by doing that, your formula will be absolute formula, absolute reference. Yeah. The next thing is to calculate the um, observation power of 2 of the observation minus mean. So here is observation minus mean. Power of 2. In order to get power of 2 is actually you need to um, press shift and 6 2, right? So in order to calculate that, you actually need to equal to column G11, press shift 6 and 2. So you get the power of 2 of the observation minus mean. and double click it, you will actually get your power of two of your observation, and then now you can calculate your variance. So in order to get the variance is the mean of the observation minus mean power of 2. So equal sum of these figures, control shift down, another one, close your bracket, and then you divide by 42, which is your numbers of population. You will get 5.76. Okay, the last one will be this standard deviation. Standard deviation is actually the square root of your variance. So you just equal to STDV. Eh, I'm sorry, it should be square root. Root of your variance. So you will get 2.40. So this is if they ask you by using the text formulas or by using the original formulas without using the Excel formulas. So for Excel formula is a bit easy. Just calculate the average. Just compared to previous one, we use sum. So this one we use average. Average of the whole thing here. Shift, go back down. Okay, the answer should be the same, 29.83. And for variance, it's equal VAR P. Yeah? So here we have two. Since this is a population exercise, so you need to use P. So select this one and take the whole thing here. Okay, and you get 5.76 summer. And the last one will be standard deviation. So this will be STDEVP. Same also within the variables. Okay, enter. So you see, you will get the same answer. So this one is much more easier and shorter, faster compared to the using text formula. But the idea is to let you understand the reason why or where does this actually originated from. So that's how it's done. And then the next thing you do is the same um, thing for the other two variables which are required. So at the end of your exercise, you will actually get all this. So this usually will get 25 marks if you got it all correct. So that's for exercise or question number one. Right now, so let's go to question number two. So question number two, question is compute descriptive statistics for liberal arts colleges and research universities in the Excel file colleges and universities. Compare the two types of colleges and what can you conclude? So first you need to download your data. So pretty much this is how the data looks like. So earlier that when you once you've downloaded this data, you actually see these two data are actually combined and all mixed up. And what you need to do is sort things out and put it into different tables lah. So you need to divide one for liberal arts type, and another one will be the university types. When they ask you for a descriptive statistics, so what you need to have is actually the mean, standard error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, and count. So there's so many things that you need to have for each of these variables that they have provided to you. So probably if you do not know the best way or the shortcuts to do all this, you might end up spending more than an hour just to figure out what to calculate. For example, like you need to calculate for the mean, so you need to type down here mean, then you need to equal to mean. So there's so many things to do. Blah blah blah, and then salah pula tu, the average. So, okay, and then yeah, so many things that you need to do. Mean, standard error, median, mode, standard deviation, sample. Wah, banyaknya benda nak kena buat. Matilah macam ni. Aduh, tolong mak. Stop it. Don't do this nonsense. Because there are easier way, my brothers and sisters. Anak-anakku, senang aja sebenarnya. So you don't waste your time. So actually in Excel there is one column or one function which they call as data analysis. In order to get this, you actually need to enable or activate your button here. So what you need to do is actually, this is for MacBook. Actually, you need to open this up and look at your Excel preferences, and you need to have your custom list. So for Windows, you probably would like to check some of the link which I provide here on how you just go to the tutorial how to actually get your data analysis button. So once you get your button, let's do the magic. So it's easy. Just click your data analysis. So there are so many analysis tools that you can use, such as ANOVA, correlation, covariance, and so many other things. Just select descriptive statistics because that is what you want to use. Click OK button and then choose your column. So median, you need to actually select from up here, control command and down for Mac, and then your output range is, should be somewhere here, just or wherever you like to place it, or down there. So click OK button. So there you go, you will have all your descriptive statistics. Excel just provide it for you. So just this is the median SAT, all right? So copy all this, just put it here so that you know that you are actually doing for which column you have actually done. The next thing to do is to calculate the descriptive statistics for all the variables here, also within the for the university column, and place it down here so that you know which one you have already done. But remember that this is percentage, so mean you need to find it in a percentage, the median percentage, mode percentage. Okay. And then you will, after you have calculated all those, you will actually have this as your final outputs. So you'll see here both the universities and the liberal arts have been calculated the descriptive statistics. The next thing to do, the question is you need to identify the conclusion that you can make. So if you look at the both statistics, you can see the acceptance rate are a bit different from between the university and liberal arts college. So you can see there are acceptance rates of 41% compared to the acceptance rates of 36%. So we can conclude that there are slight higher acceptance rates. And next thing in terms of expenditure, liberal arts are a bit cheaper or less expensive than the university rates or any other conclusion that you can make from this data, right? So if you do this, that will be also correct. So that is your question number two. So now let's move on to the question three. So question three, call centers have high turnover rates because of the stressful environment. The national average is approximately 50%. The Director of Human Resources for a large bank has compiled data about 70 former employees at one of the bank call centers. Okay, so this one you need to open up file call center data. So what you need to do is use pivot tables to find these statistics. A, average length of service for males and females in the sample. B, the average length of service for individuals with and without college degree. So C, the first instruction, I've given you the wrong one, just the average. The full question is the average length of service for males and females with and without prior call center experience. So if you choose to do this question, so you get a bonus mark for the C, which means you just need to only do the part A and B. So how to do it? Let's check it out. The call center data. Okay, so you can see all the information, gender, starting age, prior call center experience, college degree, and length of service. First, you need to highlight all this as usual and insert tables and select pivot tables. And then you choose where to place. You just place whatever you want, but it is advisable to place it just around or nearby the main tables. So you get an blank data, blank pivot table. So all you need to uh, fill up for the first one is just gender and length of service. Okay, so put it here. So check it out. So this is sum, yeah. If you want to change it to average, just uh, right click, yep, and then change here, summarize values by average. So you choose this one, and there you go. So you do want just about 2 decimal points. So you just change the decimal points to 2 for all of these numbers. Okay, so you get the first answer, eh? And then the next one is average length of service for individuals with and without college degree. So kacang je ni. So the second B is, yep, you select all this and then insert, masuk pivot table, existing worksheet, click here, okay. And then next is you select what you're going to put. College degree, yep. And also length of service. So college degree should be on the left side. Okay, and then change all this information to average, yeah. Don't forget to change. So shift, right click, summarize, not summarize, average value, and then you get it. Put it 2 decimal points, and that's it. You get it. The data for the our next question, our third question, yeah. So part C actually about the same. So question number 4 is this one. So use the descriptive statistics tools to summarize the mean, median, variance, and standard deviation of the prices of shares in the Excel file coffee shares data. Okay, this is question 4 ni pelik sikit sebab jawapan dia tu memang dah ada dalam Excel data tu. So that's kind of weird. So just skip this question lah. I'm sorry for giving you this kind of question. Uh, okay, now we move on to question number 5. So for the data in the Excel file, range Jim, find the covariances and correlation among height, weight, and BMI calculations. Let's check it out. The data of the regime. So this is the regime. So they need us to correlate between BMI, this thing here, and weight and height. BMI weight, BMI weight, height. Okay, so other things are not important, so let's just get rid of this.
Okay, delete. And then delete these two things. Just left, just leave the weight and height together with the calculations.
Right, the next thing that you need to do is we need to find out the covariances. Okay, so you have just BMI calculation, weight and height here. So what you need to do is actually you highlight these figures, and then guess what? Just click here, data analysis, covariance. Okay, alright, so A3 and C26, and your output should be anywhere you want to put. Okay, and make sure you click these labels in the first row. Okay, okay, alert, whatever. There you go. You get your answer here. And for correlation, you just do the same thing here. Just select all this data and click data analysis, and then you click correlation. Okay, and then input range is actually here. And labels on the first row, never forget that. And then your output, just select range. So just click anywhere you like, and it's visible to put on the right side or nearby the tables, the main tables, and click OK, alert, whatever. There you go. That's what we are looking for. So this one is covariance, and this is correlation. And that will be the answer for. Okay, now we move on to the question number 6. So the Excel file beverage list, beverage sales list is a sample of weekly sales at a convenience store, along with the daily high temperature. Compute the covariance and correlation between temperature and sales. So ni kacang kacang ni kalau bagi makan we use like 2 or 3 marks lah. So very senang sangat, easy, equivalent to cover. See covariance. This dude here, select my goodness. Okay, down. Array 1, comma. Don't ever forget your comma there. And another array, second array, which is here. And check back your formula what happened. Oh my goodness. Padam balik WP apa ni. Okay, it should be there. There you go. Close your bracket and click and press enter. So that will be your covariance, and since it's the money value in dollars, you should put the comma. And then the next is correlation. Senang je, you put sangkut pula, equal correl. Yeah, so it's automatically get out there, and the same array. Okay, comma, this dude right here, and close your bracket, and so we get about 0.92 correlation between both. Positive correlation, and also covariance of around 13,677.53. So that's just what you need to do. So, okay, in order to answer this question number 7, you actually need to understand this concept. So I just let you guys hear this one first.
In this lesson, we're going to talk about how to find the interquartile range, as well as the presence of any outliers. But let's take some notes first. So let's say we have a number line. On the left side, this is going to be the minimum value, and on the right side, the maximum value of the data. Now, the median of the data is the second quartile. This is basically the 50th percentile. The minimum will be at the 0th percentile, and the maximum is basically the 100th percentile. Now, Q1 is going to be the median of the lower half of the data. And Q3 is the median of the upper half of the data. And so that's how you could find the 3 quartiles. The interquartile range represents the middle 50% of the data. IQR is the difference between the 3rd quartile and the 1st quartile. And so that's how you find it. By the way, Q1 represents the 25th percentile, and Q3 represents the 75th percentile. Now let's talk about the outliers. Sometimes you may have a data point that is either all the way to the right, that's very high, or to the left, that is very, very low. Now, here's what you need to do in order to find if a number is an outlier. The outliers will exist outside of this range. It's going to be outside of Q1 minus 1.5 times the IQR value to Q3 plus 1.5 times the IQR value. So if you have a number that's in the list and it's not in this range, it's outside of it, then that number is considered to be an outlier. And we're going to do some examples so that you can see how this process works, like how we can go about determining if a number is an outlier or not. So let's say if we have the numbers 5, 8, 15, 26, 10, 18, 3, 12, 6, 14, and 11. So let's go ahead and find the IQR value, and let's see if there's any outliers in this list. So what's our first step? What's the first thing that we need to do here? The first thing you want to do is you want to rewrite this and arrange the numbers in ascending order. So 3 is the lowest number. Next we have 5, and then 6, and then after that is 8, 10, 11, and then it's 12, 14, 15, 18, and then 26. Now the next thing you want to do is identify the median of the entire data set. So the median is basically the middle number. If we eliminate the first 2 numbers on both sides and then follow that process until we get one number in the middle. So this is the median. So 11 is the second quartile. So what I'm going to do is I'm going to draw a line here, and I'm going to put 11 below that line. So this is Q2. Our next step is to identify the median of the lower half of the data. So the middle number of these 5 numbers is 6. So let's put a line. And so 6 is going to be Q1, the first quartile. Now let's do the same thing on the right side. Let's identify the median in this area. So the middle number is 15. So 15 is the third quartile. When you think of the word quartile, I think of quarters. 4 quarters equal $1. And so the quartiles, they divide the data into 4 equal parts, as you can see here. Now at this point, we can calculate the IQR, the interquartile range. It's the difference between the third quartile and the first quartile. And so we can see that the third quartile is 15 and the first quartile is 6. So 15 minus 6 gives us 9. And that's how you can calculate the interquartile range. Now our next step is to determine if we have any outliers. So looking at the numbers in this list, do any one of these numbers stand out? Is there a number that appears not to belong to the rest of the pack? Now to me, 26 seems to be a little far out from all the other numbers. So is 26 an outlier? Let's find out. So what we're going to do is we're going to plug our data into this interval, Q1 minus 1.5 times IQR, and then Q3 plus 1.5 times the IQR value. So Q1 is 6, and the interquartile range is 9. Q3 is 15, and then it's going to be plus 1.5 times 9. 1.5 times 9, that's 13.5. So 6 minus 13.5 is negative 7.5. And then 15 plus 1.5 times 9, that's going to give us 28.5. Now an outlier will be any number in this list of numbers that is not in this range, or that is outside of that range. So is 26 outside of this range? 26 is in this range. So therefore, 26 is not an outlier. Now, let's say if this was 29, then it would be an outlier. Let's try another example. So let's say we have the numbers 11, 31, 21, 19, 8, 54, 35, 26, 23, 13, 29, and 17. Go ahead and pause the video and try this example for yourself. Calculate the interquartile range and determine if we have any outliers in our dataset. So let's begin by writing the numbers in increasing order. So we have 8, 11, and 13. So after 13 we have 17, 19, and 21. And then after that we have 23, 26, and 29. And then the last 3 numbers are 31, 35, and 54. So we have a total of 12 numbers. Our first step is to calculate Q2, the second quartile, thus splitting the data into two equal parts. So if we eliminate the first two numbers on both sides and then follow the pattern, notice that we have two numbers in the middle. So to calculate the second quartile, we need to take an average of those two numbers. So we can add them up and then divide by 2. 21 plus 23 is 44. 44 divided by 2 is 22. So this is the second quartile. Now we have 6 numbers on the left and 6 numbers on the right. So now we need to find the first quartile. So what is the median of these 6 numbers? If we eliminate these two and then those two, we have 2 numbers in the middle, so we need to average those 2 numbers. That was weird. So we're going to split the lower half of the data into 2 equal parts, where we have 3 numbers on the left, 3 numbers on the right. So the average of 13 and 17 is going to be the middle number between those two, which is 15. So 15 is the first quartile. Now to find Q3, we need to split the upper half of the data into 2 equal parts. In this case, 2 parts of 3s. So the average of 29 and 31 is 30. So 30 is going to be the third quartile, our Q3 value. Now once you have Q1 and Q3, you can now calculate the interquartile range. So it's going to be 30 minus 15, which is 15. And so this is our IQR value. Now let's focus on any outliers. 54 seems to be a very high number. Could this be a potential outlier? Let's find out. So first, let's write this expression. Q1 minus 1.5 times the IQR value, and then Q3 plus 1.5 times the IQR value. So Q1 is 15, and the IQR value is also 15. Q3 is 30. One point five times 15 is 22.5. And so if you take 15 and subtract it by 22.5, that will give you negative 7.5. Now 30 plus 22.5, that will give you 52.5. Now notice that 54 is outside of this range. Because it's outside of this range, 54 is an outlier. So I'm going to put a check next to it. And so now you know how to determine if a data point represents an outlier in the data set. And you also know how to calculate the interquartile range. So that's it for this video. Thanks for watching.
Information. So this is our wedding data from our event data Excel. Okay, what we're to do is the first question is looking for the mean, yeah. So mean average lah, equal to average. Okay, average this column, this row right here, and then I enter. So you get 25,000. And then next thing to do is look for the median. So equal to median. Enter. And then the third one is looking for standard deviation. So should be standard deviation there. Then just Okay, good. And then next thing is we're going to check out the outliers. First is to find out the quarters. So next we look for the quarter one. How we're going to do it Excel is actually find for quartile, quartile INC, and then select this wording right here. And then for quarter one, we just put one, close bracket, and you get the first quarter data. And for Q2 is the median, and then Q3, we look for the Q3 quartile INC, then select all this data, and then you put third quartile, close bracket, and then there you go, get the data for the third quartile. Then the next thing is we are going to look for the interquartile, which is Q3 minus Q1. So this one minus this figure here. So there you got it. So first we need to find out the Q1 minus 1.5 IQR. So Q1 minus 1.5 IQR. So which is equal to Q1 here. Okay, minus 1.5 times IQR. And then another one is Q3 plus 1.5 IQR, which is equivalent to Q3 plus 1.5 times IQR. Okay, yes. So if we see the data here, anything which is not within this area is actually the outliers lah. So we can see here from the top three weighting courses. So this three is actually a bit outliers lah. Okay, just highlight these three figures. So all these three is actually outliers. Okay. So if this bride or the couple would like to consider to recalculate their mean, median, and standard deviation, so we create a new one here, new mean, median, and SDV. Just copy here, paste the data here. Angkat je. Just pick it up and just take this three, exclude this three figure. Same right here, just exclude the three figure here. And also the figure right here. So this is their new mean, median, and standard deviation. So that's it for, it's actually got a longer way to understand about their budget. Anyway, this is ample enough for your understanding. So let's move on to the question number 8. Okay, for the last question, question number 8 is the question is for the Excel file credit risk data, compute the correlation between age and months employed age and combined checking and savings account, balance and the number of months as a customer and amount of money in the bank, and interpret your result. So now you look at all this data here. Okay, so let's check it out what we have. Age, yep, you have age and the total okay, age, combined checking and saving account. Okay, combined checking and saving account balance. So do we have that in our data? Tak ada so we don't have that, so we just need to add up a new column right here, insert, so total, so campur ni dua, so you get your combined. Okay, now let's see the correlation. First is the age versus months employed. So do this a little big, and then equal to what will do the function is correlation. So between age against months employed, and close your bracket, and oh, don't forget to put a correlation, and make it as two decimal points. And then the next is age against the combined income, combined income, equal to correlation age, comma, and also your combined income. Close your bracket and press enter, make it as two decimal points. So the next thing is the last one is months as a customer versus money in bank. So it's correlation function, and then you take age and also no, not age, I'm sorry, it should be month as customer against your total money in bank, which is column D4 until D428. Okay, and close the bracket, and there you go, you get it, and make it as two decimal points. So from this data, let's conclude. So you can see that there are positive correlation between age versus month employed, which means that older customers tend to get employed longer. And then the next thing is there are no significant relation between age and money in bank, because of you see that negative relationship, which is 0.02. And the last one is no significant relation between months as a customer and money in bank, so because of the low correlation. So I just write it down here. So that's it. The your answers for your tutorials. Hope you guys learn something from these exercises and do more as I will be giving you more. And with that, thank you very much and see you soon.